Warm greetings from C3S. We welcome you all to the C3S podcast on China's weaponization of space. In the coming years, the ability of outer space to support military operations and make vital battlefield decisions will play a significant role. Great powers have long pushed to weaponize space, and they will likely continue to do so in the coming years. To give a deeper understanding on this topic, we have with us Mr. Subramanyam Sridharan. Mr. Subramanyam Sridharan is a computer scientist by education and profession. He served in technical positions in one of the leading IT companies abroad before returning to India to head some of the divisions of the same company from India. He has been a keen observer of international relations for nearly 3 decades, being also an administrator for an internet based forum that discusses India's strategic security. He has interest in Indian foreign policy and closely follows events in Pakistan, Afghanistan, and China. Mr. Subramanyam Sridharan is a distinguished member of C3S. Welcome to the interview, sir.
Thank you, Sapna. Thank you very much.
Let me begin the interview by asking the first question, sir. Presently, we are at an era that is witnessing increased human activities that extends beyond the Earth's atmosphere. So governance becomes a very important aspect of this. So could you give us a broader overview of this present treaties and conventions on space governance for our viewers?
Yeah, sure. There are practically three broad aspects to space activities: exploration, exploitation, and militarization. The Chandrayaan and the Mangalyaan projects of ISRO, the Apollo program of the US, or the lunar moon programs of the USSR fall under the exploration part. Placing communication satellites, Earth observation satellites, mining the moon, and asteroids come under exploitation. Space militarization and weaponization use space for destructive purposes. Exploration and exploitation could also lead to militarization and weaponization because of the desire to colonize celestial bodies and outer space and to nullify advantages to the enemy. As our knowledge of space improves, as technology advances, and as more nations and private players begin to access space, the need for regulation to access to space and to exploitation of outer space becomes important. There is no single convention today for managing outer space as it exists for managing the seas through UNCLOS, however ineffective UNCLOS might be. However, there is a number of UN-sponsored and proposed agreements and conventions. We will see here some of these which are of interest in the context of militarization and exploitation. Space race as part of Cold War 1.0 started as soon as the then USSR launched its first satellite, Sputnik 1, on October 1, 1957. The UN set up UNUSA, UN Office for Outer Space Affairs, in 1958, which in turn set up a Committee on the Peaceful Uses of Outer Space, COPUOS, Committee on the Peaceful Uses of Outer Space, in 1959. COPUOS produced an Outer Space Treaty in turn, OST, in 1967, to which all UN member nations acceded. The OST, the Outer Space Treaty, remains the gold standard for space activities even after 5 decades. We will refer to the OST in the rest of the podcast. 3 of OST's important clauses are that all activities of outer space would be for the benefit of the entire human race. Outer space, which included moon and celestial bodies, cannot be appropriated by anyone. And no weapon of mass destruction, WMD, can be placed in orbit. OST also prohibits the testing of weapons or conduct of military maneuvers on celestial bodies. However, it allows the use of military personnel or any equipment or necessary facility for peaceful purposes on the moon or other celestial bodies. So you can see that some of these rules are made with respect to moon and celestial bodies, but not all of them are made with respect to generally what we know as the outer space. The OST's vagueness, therefore, allows for interpretations that permit military activities that can be defined as non-aggressive or defensive in nature. In fact, except for stationing WMDs, all other forms of military activities are permitted in outer space by the OST. This is why anti-satellite weapons and other forms of militarization of space continue increasingly. In 1984, the UN's Moon Agreement came into force. But unlike the OST, this has been signed only by 18 countries and ratified by even less, that is, only 7 of them. Major spacefaring nations such as the US, Russia, China, India, and Japan are not signatories. The Moon Agreement reaffirms and elaborates on many of the provisions of the OST, the Outer Space Treaty, as applied to the Moon and other celestial bodies. The agreement provides that the Moon and its natural resources are the common heritage of mankind, and that an international regime should be established to govern the exploitation of such resources when such exploitation is about to become feasible. However, the Moon Agreement allows the extraction of samples for scientific purposes. The UN then came up with a space debris migration guideline in 2007. Space debris is created by dead satellites which have gone long past their life, or spent stages of the rockets, etc. And they circle the Earth for a long time, causing a grave danger for new satellites or manned missions or international space stations. A very large launch of small CubeSats in recent times exacerbates the debris problem. The 2007 guideline stresses, I quote, the intentional destruction of any on-orbit spacecraft or other harmful activities that generate long-lived debris should be avoided, unquote. All ASAT, that is anti-satellite weapon tests, produce a large amount of debris. One Chinese ASAT test of 2007 alone, produced over 10% of all space debris. As already seen, the OST has no provision to ban the use of ASATs. As such, a broad loophole exists for states to continue endangering all spacecraft by conducting these exercises. India's radar imaging satellite, RISAT-1, which was launched in 2012, was hit by space debris in 2016 and it became inoperative. Prevention of Arms Race in Outer Space, or PAROS, is a 1981 UN document that further reaffirms the OST by taking the weaponization of space issue to the UN Committee on Disarmament, that is CD. The UN Committee on Disarmament, which functions out of Geneva, deals with disarmament, weapons of mass destruction, and confidence building measures. However, the US refusal to allow PAROS to function eventually led to its demise in 1994. Russia and China have jointly proposed an arms control agreement for outer space. The Russia-China document, called PPWT, Prevention of Placement of Weapons and Threat in Outer Space, is based on their understanding and interpretation of PAROS and was submitted to the CD, the Conference of Disarmament, in 2008. On June 10, 2014, China and Russia introduced an updated PPWT in the Conference on Disarmament. However, PPWT suffers from their total silence on anti-satellite weapons. In the meanwhile, the European Union proposed an international code of conduct for outer space activities, usually referred to as the Code, which, apart from encouraging transparent space policies by individual nations, also talks about reduction of space debris, thus addressing the ASAT issues. The US, for its part, has been working for the past decade on taking humans to Moon once again as a stepping stone to going to Mars. The program is called Artemis, after a Greek goddess. As part of this space exploration, the US is developing space rules called Artemis Accords. in collaboration with other countries. The US intends to submit a copy of the Artemis Accords to the UN for circulation to its member states. Because of the dual nature of many space technologies, any arms control regime or space weapons ban is inherently unverifiable. This then is a brief overview of existing and proposed treaties and conventions on space governance.
We can usually classify space development into two: one for the social and economic development, and the second for strategic and tactical, that is, the military applications. Speaking of the latter, what are China's ambitions in using space as a domain to exercise its power, that is, the militarization of the space? And what capabilities does it possess as of today? And could you also, for the understanding of the viewers, uh, differentiate between militarization and weaponization of space?
Yeah, sure, Sapna. There are 5 objectives to China's space program. These are using space for national security and war-winning strategy, national and international prestige to eclipse the United States, become a sole preeminent space superpower by 2050, exploit the resources of the outer space and celestial bodies, and finally, to be in a position to shape the rules for space-based activities, as the submission of the PPWT Accord that I just a while ago referred to indicates. The origins of the Chinese space program show its purpose. The Chinese space program, unlike that of India, was started in the 1950s under the PLA's 2nd Artillery, that is the People Liberation Army's 2nd Artillery Regiment. The 2nd Artillery remained the strategic forces of PLA until 2016, when it was split into a rocket force, PLA-RF, and a strategic force, SSF. The anti-satellite weapons seem to be under the control of PLA-RF. Largely, therefore, Chinese space program is inextricably associated with its efforts at revolutionizing its military affairs, that is RMA. 5 of the areas where the Chinese are concentrating today in counter-space operations are anti-satellite weaponry, directed energy weapons or DEWs, signal jammers, space-based bombardment systems called FOBS, and rendezvous and proximity operations or RPOs. We will see them one by one. The first of the Chinese space weapon is the anti-satellite weapon or ASAT. The Chinese first conducted their ASAT test on January 11, 2007, and the Dongmeng-1 missile, a modified version of its SC-19 anti-ballistic missile, launched from Xichang in Sichuan province, successfully destroyed a defunct Chinese weather satellite at an altitude of nearly 900 kilometers. This was a direct ascent kinetic kill vehicle, that is DAKKV, direct ascent kinetic kill vehicle, as the missile directly ascended from the launch pad without going into an orbit and used its kinetic velocity to kill the satellite. In 2013, a likely non-destructive test of DAKKV weapon using an upgraded DN2 missile that could reach a higher orbit took place from Xichang in Sichuan. This was to provide capabilities to kill geostationary satellites, which orbit at a much higher altitude of nearly 36,000 kilometers. They now have a DN3 missile, which combines elements from both the SC-19, which is an anti-ballistic missile, and DF-21, which is a medium-range ballistic missile, that is an MRBM. The new DN3 can interchangeably be used as an ASAT weapon or as an ABM weapon, anti-ballistic missile weapon. China has also conducted 6 land-based mid-course anti-ballistic missile tests in 2010, 13, 14, 18, 21, and latest in June 2022. The trajectory of ballistic missiles has 3 phases: the boost phase, when the rockets fire; the mid-course phase, when the missile cruises much above the atmosphere, and the terminal phase, when it re-enters the atmosphere and hits the target. These anti-ballistic missiles are designed to destroy the incoming ballistic missiles in mid-course before they start their terminal phase. Because terminal phase, it becomes very difficult to destroy because of the high speeds and the maneuverability of the missile. There is only a thin line that separates an ASAT test from an ABM test. Apart from the direct ascent kinetic kill vehicle, there can also be co-orbital ASAT weapons. These are payloads which are already in orbit, maybe even for months or years, which can release a killer payload that then destroys an enemy satellite. These are aptly termed space torpedoes. One variant of them is the parasitic microsatellites, which are inexpensive as they could weigh not more than 10 kilograms, which can crash into a bigger satellite upon command. Please realize that even a 10 centimeter size space debris can destroy a satellite, as it happened to India's RASAT-2 in 2016. In 2008, the BX-1 microsatellite released by China passed dangerously close to the International Space Station, which would have destroyed both objects had they collided. The second counter-space armament is the directed energy weapon, or DEW. China has huge and matured programs in the DEW arena. DEWs use concentrated electromagnetic energy to attack enemy assets in space. DEWs can be either ground-based or space-based. Currently, Chinese DEWs operate from the ground. They are solid-state or hybrid gas and solid-state based. The DEWs, which are lasers, actually lasers, can dazzle, blind, or destroy the satellite. The effects of dazzling are temporary on the electro-optical sensors of the satellite, while the enemy satellite flies over the sensitive areas so that they cannot film the area. Blinding causes more permanent damage to the sensors, while destroying could vaporize the satellite or portions of it. It was reported as far back as in 2006 that China used ground-based laser to dazzle or blind a US optical surveillance satellite on at least one occasion. China has been regularly using lasers against unfriendly aircraft or ships in the Indo-China Sea or East China Sea. China has at least 5 sites that support China's DEW work. China is planning to deploy, by next year, a ground-based laser with 1 petawatt or 10 to the power 9 megawatt capacity. 1000 megawatts are 1 gigawatt, 1000 gigawatts are 1 terawatt, and 1000 terawatts are 1 petawatt. China is also working on space-based DEWs, the next evolution. By 2023, China is expected to have a space-based chemical laser weapon of 5 tons capacity with 2.5 tons of chemicals for laser use. It can fire a 1 megawatt laser for 100 seconds. Ground-based radar would provide coarse tracking information to space-based laser system, which will then use its own electro-optical sensors to get a very accurate tracking of the enemy satellite, followed by firing the space-based laser at the satellite. The advantage of co-orbital laser is that since it does not need to penetrate the dense atmosphere, power requirements are lower. Since distance to an enemy satellite is very small, accuracy is also higher. However, these are technologically most challenging to develop due to requirements for miniaturization and space hardening. The third arrow in the Chinese quiver is the jammer. The establishment of the Strategic Support Force in December 2015 was tasked with integrating space closely into operations, military operations. In terms of counterspace, the SSF Space System Department appears to be responsible for at least the co-orbital counterspace mission. The SSF's Network System Unit indicates that it is responsible for jamming SATCOMs, satellite communication, and GPS, as well as computer network operations against space facilities and satellites. Direct ascent capabilities, which we discussed a little while earlier, have been retained by PLA Rocket Force, or the PLA RF. China has developed three space-based systems for jamming enemy satellites: the radio frequency jammers, chemical sprays, and relativistic klystron amplifier, also known as RKA, relativistic klystron amplifier. Of these three, radio frequency jammers have been in existence for a long time. Chemical sprays can damage the sensors or the solar arrays, thereby reducing the electricity generation. A klystron amplifies microwaves. A relativistic klystron amplifier is a device that can generate wave burst measuring 5 megawatts. It can be payload of a satellite that can then be used to target other satellites. China claims that it has developed such a device. The fourth, and by far the most dangerous, are the space-based bombs. In a most startling development, China announced last year its Fractional Orbit Bombardment System, or FOBS. FOBS is a hypersonic vehicle that goes into near-Earth orbit initially. It will have a perigee, that is closest point to the Earth, of 160 kilometers, and an apogee, that is the farthest point from Earth, of 200 kilometers. FOBS offers three advantages: unlimited range and time. Attack can be carried out from any direction. The enemy would have very little time to react. FOBS gives hardly 5-minute window of warning, while with the traditional ABM defense systems, such as ground-based radars and space-based infrared systems, the window can be between 15 and 30 minutes. The fifth and the last are the rendezvous and proximity operations, known as RPO, where one satellite approaches another one as if on a rendezvous or a meeting. RPOs are used to gather space situational awareness for any later action. While RPO can also be used to service failing satellites or for removal of space debris, it can be used to inspect and gather intelligence of enemy satellites too. Besides, these RPO satellites can be equipped with robotic arms for good and bad purposes. While a robotic arm can be used for space debris removal, it can be also used for changing the orbit of an enemy satellite, thus rendering it useless. For example, on January 22 this year, the Chinese Shijian-21, meaning roaming dragon, Shijian meaning roaming dragon, satellite, grabbed a defunct Beidou 2 navigational satellite with its robotic arm and pushed it to a graveyard orbit. 4 days later, the same SJ-21 returned to its geostationary Earth orbit location as if nothing happened. Thus, SJ-21 acted as a space tug. While capturing a defunct satellite and moving it to a graveyard orbit is a useful space debris cleaning exercise, this also demonstrates an ability to use such technology for offensive space purposes against other nations' satellites. This makes space awareness an important domain for other nations to guard themselves against hostile intents. Such a satellite with a robotic arm is called a scavenger satellite. For this reason, China has built SSA, or the Space Situational Awareness radars, for detecting, tracking, and characterizing space objects. Such SSA radars also play a missile warning function dual role. While China does not have such radars beyond its borders, it is developing ships with such radars that can be positioned at various places around the globe. The Yuan Wang 5 ship that docked at Hambantota on August 16 this year is one such ship.
So, space is common to all, and cooperation in this field is very important. Until a certain point, we saw cooperation in space being successful despite differences. In March 2022, Russia withdrew its support from the International Space Station. In terms of cooperation, are Russia and China coming together in certain areas? If so, what are the areas and what are your views on this?
This is a very good question, Sapna. I will not go into the various aspects of the US-Russia collaboration on the ISS platform because it has a long history. But recently, that collaboration or cooperation has frayed for various geopolitical and geostrategic reasons. While the US-Russia space cooperation has gone southwards in recent times, China and Russia had signed a 5-year space agreement in 2018, which is being extended for another 5 years now. Chinese and Russian officials have proposed an international lunar research station called ILRS that they would jointly develop near the south pole of the moon. On March 9, 2021, the China National Space Administration, CNSA, and the Russian Space Agency, Roscosmos, signed a memorandum of understanding for the joint construction of a permanent research station on the moon. Their explicit goal is to make this base for future space exploration operations, with the implicit goals of planning a crewed mission to the Mars and boldly challenging the US leadership in space. They have outlined a 3-phase approach to developing the ILRS. Late last year, Russia and China decided to establish satellite ground stations in each other's territories. The GLONASS, which is the Russian positioning system equivalent to the American GPS, and Beidou, which is the equivalent Chinese system, are combining together to overtake the GPS as the most available system worldwide. This has military implications too, as Russian and Chinese missiles can cover the gaps in their respective positioning systems by combining the military-grade signals of the two systems. They could also join together to jam the GPS signals of the US GPS system, thereby rendering American missiles ineffective. As a result, the US is now building jam-proof GPS-3 satellites. China also is reported to be developing, in collaboration with Russia, RPO systems, RPO meaning rendezvous and proximity operation that we saw just a while ago, such as orbiting satellites that can approach other satellites and disable or destroy them using high-power microwaves, jammers, lasers, chemical sprays, or to blind the enemy satellite's optics, or through robotic mechanisms. Media reports talk of Russia developing a ballistic missile early warning system, that is BMEWS, Ballistic Missile Early Warning System, as part of a contract from China. The ground stations located in each other's countries could provide warning data to each other. So China-Russia collaboration and cooperation in space continues on all facets in spite of the fact that Russia may be very wary of sharing technology, data, and expertise with China.
So, predominantly, India has used her space program to achieve space science and technology for national development. In terms of capabilities, where do we stand against China, and what can be done to improve our strengths?
Yes, that's correct. India took a conscious decision to separate the civilian space activities of the ISRO, Indian Space Research Organization, from the military's Defense Research Development Organization, that is DRDO. This is how it has continued ever since. However, the DRDO was concentrating on conventional systems and not much on space until recently. The 2007 ASAT test by China jolted India. The then Defense Minister A.K. Antony asked a very pertinent question: how long India would remain committed to the policy of the non-weaponization of space, even as counter-space systems are emerging in India's neighborhood? That was the question he asked. India then began to take space seriously for its own defense. It embarked on 4 programs to improve C4ISR, that is computer, communication, command, control, intelligence, surveillance, and reconnaissance capabilities. The 4 space-based broad programs were: 1. Using space for secure and reliable communication for the armed forces. 2. Using space for intelligence gathering, both ELINT, that is electronic intelligence, which is targeted at knowing about the location and characteristics of enemy radar sites, etc., and COMINT, that is communication intelligence, which is to eavesdrop on enemy communication channels. 3. Earth and ocean observation through optical and radar imaging satellites. And 4, deploying positioning satellites, ballistic missile defense, and ASAT capability. The following information, which I'm going to talk about, is gathered from OSINT, that is open source intelligence. Today, the Navy, Air Force, Army, and the strategic forces of India have dedicated satellites with some special capabilities like spot beams, which can narrow the beam to a particular location within India. We launched a dedicated ELINT, or the Electronic Intelligence Satellite, EMISAT, in 2019. We have radar imaging satellites like TESS, Technology Experiment Satellite, and RISAT, Radar Imaging Satellites. In early next year, we will launch an ISRO, NASA, Synthetic Aperture Radar, that is SAR, satellite, called the NISAR, which will carry 2 SARs, one from each nation. A SAR improves dramatically the detection capability. We have electro-optical satellites like QuarterSat with sub-meter resolution of the picture. We have also built Indian Regional Navigation Satellite System, IRNSS, also known as NAVIC, a constellation of 7 satellites which provides positioning information for navigation, like the US GPS, the Russian GLONASS, the Chinese Baidu, or the European Galileo system. IRNSS signals are available up to 1,600 kilometers from our borders. IRNSS provides both civilian and restricted and encrypted military-grade signals with a supposed accuracy of 10 centimeters for military-grade positioning and about 20 meters for civilian positioning. This should improve tremendously the circular error probable, that is the CEP, of our missiles. The CEP is a measure of the accuracy of the missile. In the case of ballistic missile defense, that is BMD, we have the capability to shoot down medium-range ballistic missile class, that is IRBM, MRBM class missiles, in both endo-atmosphere, that is within the atmosphere, at altitudes of up to 40 kilometers, using the Prithvi Defense Vehicle, or PDV, and exo-atmosphere, that is outside the atmosphere, at 180 kilometers, using the Ashwin Air Defense missile. The next phase is to tackle the ICBM class of missiles, which are hypersonic missiles, at greater than 5 Mach. 1 Mach is 1,225 kilometers per hour. PDV, the exo-atmospheric kill vehicle, is actually a predecessor to another exo-atmospheric interceptor, supposedly currently under development, that can neutralize incoming missiles at altitudes of over 300 kilometers. The March 27, 2019 ASAT test proved this capability. The March 27, 2019 ASAT test hit a satellite traveling at 7 kilometers per second, but the ASAT missile is actually capable of hitting an object moving at 10 kilometers per second at altitudes of up to 1,200 kilometers. This helps the phase 2 of the 3-layered, 3-phase ballistic missile defense program. Taken together, this means that India has all the elements in place for a direct ascent counter-space system that can potentially be used for BMD as well as anti-satellite purposes. The March 2019 ASAT test proved India's capability in this class of weapon, but as a responsible space power, India hit a defunct satellite at only a height of 285 kilometers, and the angle of attack was such that it created the least space debris. At that height, the debris would not pose danger to most satellites or space stations, as they all operate above 400 kilometers. Also, the Indian debris would re-enter the atmosphere quickly and burn up, as it eventually happened. The final piece of decayed debris from orbit fell on 14th June 2022. This is unlike the 2007 test of China, when it hit the satellite at about 900 kilometers, generating over 3,000 pieces of trackable debris, which would take decades to decay. The residue fragment from this 2007 test collided with a Russian satellite on January 22, 2013, almost 6 years later. As for directed energy weapons, that is DEWs, we are supposed to have a ground-based weapon known as KALI, K-A-L-I, that is kilo-ampere linear injector, which is supposed to exist with a 40 gigawatt beam pulse. There is no more information in public domain about this weapon. GOI, the Government of India, refused to give details about this project in the Parliament recently. Smaller power DEWs are being tested for anti-drone purposes. As part of our Chandrayaan and Mangalyaan missions, we have developed our deep space communication capabilities. Both the Chandrayaan and Mangalyaan missions showed our capabilities to insert the orbiter around the Moon and the Mars, which are tricky maneuvers at the very first attempt itself. We have no dedicated setup today for space situation awareness, that is SSA, although ISRO tracks space objects in order to protect its launch vehicles and operational satellites. But SSA goes far beyond that as it identifies each space object and tracks it. We also do not have capabilities for rendezvous and proximity operations, that is RPO operations, nor are our satellites equipped with docking mechanisms or robotic arms. In 2019, the Defense Space Agency, DSA, a tri-service agency, has been formed, and all scattered defense space activities such as imagery processing and defense satellite control have been brought under DSA's control. The Defense Space Agency will grow into a full-fledged space command in the years ahead. In June 2019, India announced its first simulated space war exercise, Space X. The exercise was basically a tabletop war game, with all stakeholders from the military and scientific community taking part in it. But it does underline the seriousness with which India is taking the need to counter likely threats to its space assets from countries like China. By comparison with India, as of May 2018, the Chinese reconnaissance and remote sensing fleet consisted of more than 120 satellites. About half of these systems, operated by the PLA, provide support for monitoring, tracking, and targeting. These satellites also allow the PLA to maintain situational awareness of China's regional rivals, such as India and Japan, and potential regional flashpoints like Korea, Taiwan, and East and South Indochina Seas. In 2021, we had 2 launches, while China had 55 launches. So that is the big gulf between the two countries. In terms of what we can do to improve our military's access to space, it is time for us to formulate a space security policy to identify all threats and future scenarios. We should then develop specific capabilities in line with our national objectives. There is an urgent need for space domain awareness, that is SDA, akin to the maritime domain awareness among friendly countries. The Quad leaders in their May 2022 summit announced IPMDA, Indo-Pacific Maritime Domain Awareness Program. They should also announce a similar effort for space domain awareness.
So can you throw some light on the outer space explorations and utilization of space resources? China has shown significant interest in the moon dust, which could pave way for future mining. Your thoughts on this, sir?
Yeah, the late Stephen Hawking, the celebrated physicist astronomer, said before his death that human beings have to develop the ability to migrate to other celestial bodies within 100 years. Initially, he said 1,000 years, but later he revised the estimate downwards to 100 years. So that shows the urgency with which we have to go to these celestial bodies. Exploration of celestial bodies have been going at a rapid pace. The Artemis Accords by the NASA, the International Lunar Research Station, that is ILRS by China and Russia, and the plans by the US-based private space company SpaceX to create settlements in Mars are pointers to these developments. They all intend to use the moon as a base. The water in the moon detected by Chandrayaan-1 would be used to create fuel, liquid oxygen and liquid hydrogen, for the onward journey from there to Mars. Besides, moon has abundant helium-3, an isotope of helium, which is very rare on planet Earth. helium-3 can be used in newer fusion reactors without generating the nuclear waste that the present generation nuclear generators do. Moon will also be explored for rare earth elements which are not in big supply on Earth. The asteroids are made up of enormous quantities of various minerals. Japan has successfully sent 2 missions, Hayabusa 1 and 2, to mine and return to Earth the samples. The Apollo program of the US collected over 300 kilograms of moon samples, while China's Chang'e 5 last year collected 2 kilograms. Though the exploitation of space resources is at a very preliminary stage, the plans into the near future are ambitious. India must also pay attention to this arena to gain first mover advantage. We have to learn a big lesson from our adamant attitude of not exploding a nuclear weapon in the 1960s, which robbed us of a seat in the high table later on. Thank you, Sapna.
Thank you very much, sir. It has been an enlightening session. You were able to explain many concepts and terms that were very vital for this topic. I am sure that our listeners will be able to gain a lot from this discussion. Thank you very much, sir, for taking out time from a very busy schedule and giving us this interview. We look forward to many more such informative sessions with you, sir.
Thank you, Sapna. Thank you, C3S, for giving me this opportunity. Thank you very much.
Thank you, sir.